Now, this is the first thing that I would like to make sure that you can say, oh, she doesn't want to talk about this anymore. I really don't. I want us to talk about it today, embed it in our memory, and move forward with it in here. If 2 weeks from now you're going to ask me a question about it, I'm not going to say no, I'm not going to answer. I will answer. If 3 weeks from now or 2 months from now even you have a question on this, I'm going to answer it. But I will think in these terms, and I would like you to remember this. My student has not accomplished much if he or she is still asking about this. I will think about it, honestly. I will sit down with you aside and we'll go over these problems again, but I would like us to commit this to memory now and forget about it, in the sense, and not forget about it, but forget about it in the sense that we accumulated this. We have it under our belt. We understood it, it's embedded in our brain, and it's done and over with, okay? So this is the first step in algebra. Being able to apply these, going back and forth from the left-hand side to the right-hand side, and from the right-hand side back to the left-hand side. This one is called expanding. This one is called factoring. We need this both ways. So I would like to start by embedding it in our memory now and forget about it. Okay, so can anyone tell us what is A plus B? Do we know the name? The terminology, it's like a foreign language. We have to know minimum terminology. So what is A plus B? How is it called? An equation has to have one side, an equal symbol, and the other side. So true, but there is no other side here, right? So it cannot be an equation. And it's an expression. Good. So, but it has a name. Awesome. It is a binomial because we are adding or subtracting two quantities. Very good. It is a binomial. Excellent. So now the next question to you is, what does A plus B squared equal to? If I ask you what is 2 squared, you will say, easy, 2 times 2. But if I ask you what is A plus B squared, what will you say? Okay, so you're saying, say it again. Okay. Do not write this. Okay. I would like you to understand the difference between this and this. What is the difference? This is how many terms? This is how many terms? 1. So they are treated differently. They have to be treated differently. So what will this equal to? Because this is easy. Very good. This part is easy. But this one cannot be the same. So I cannot really treat the positive and the multiplication in the same way, right? So obviously, we have a problem with that. So one more time, I gave that example. And I said 2 squared. What is 2 squared? 2 times 2. So what is A plus B squared then?
Plus AB.
Awesome. That's all I wanted you to know, to tell me for now. So it's A plus B and A plus B. So what am I multiplying here then? I'm multiplying 2 binomials. Good. What is the procedure of multiplying 2 binomials? It's called? Excellent. So let's do FOIL for now. It is crucial to understand the difference between these 2 expressions. And do not apply what you do here to this. Okay? So, can anyone dictate the FOIL for this?
A times A.
Good, which is A. Awesome. How do we know that A times A is not 2A? Because I'm not saying an apple plus an apple, which is 2 apples. I'm saying A times A. I'm saying feet times feet. So when I buy carpet, I'm not going to tell them that I want 50 feet. I'm going to say 50 50 feet squared or square feet, right? Because it's foot times foot, right? It's foot squared. Copy the base at the exponents. Very good. Now I'm here. Plus a times b. Awesome. Plus b times a. Of course. Plus b times b. For some of you who don't remember this may be fast. If you need to see me after class or you want to ask a question, stop me now. Okay, what would be the next step? Of course, I have to combine like terms, and then a squared is a squared, and now I have an apple plus an apple, which is 2 apples, and plus b squared. There is nothing else I can do here. No one can further simplify this expression. We agree or we disagree? Agree. Is anyone left behind? Okay, now I would like you to do this for me. I'm going to replace this by ft. What do you think ft means? First term. Exactly. Plus, because it doesn't have to be a. It doesn't have to be a, it doesn't have to be x, it doesn't have to be anything in particular. It's just the first term in general. Plus, what do you think I'm going to write for instead of b? Of course. And now squared. I would like you to just follow the pattern. This is our discovery. We discovered that a binomial, this is what we discovered. We discovered that a binomial squared is what? How do we call this one? So a binomial squared equals a trinomial. This is our discovery. And we have to commit it to memory. When I square a binomial, I must get a trinomial as the answer. Otherwise, it's wrong. So when I square binomial, I cannot get 2 terms. I must get 3 terms. So now can you mimic this and tell me what to write? If the first term is just any term, first term, whatever it is, and the second term is the second term, whatever it is, not necessarily b, it could be b, but not necessarily. Can anyone dictate what I should write?
ft squared plus 2ft st plus st squared.
That's all I need to remember. And you can make a tune out of it. First term plus second term squared is the first term squared plus 2 times the first times the second plus the second term squared. I know that was fast. Like my colleague who says, do this. I said, I need time. Okay? But that's what it is. First term squared plus twice the first times the second plus the second term squared. So I'm hoping that moving forward, no one would ask, where does this 2 come from? Where did you get it? Yes, where did we get it? We got it from adding 2 terms that are the same. That's how we got this 2. So now I would like us to go back to our form so you can keep this. And please remember, keep all these documents together in a folder and bring it to class. Bring the folder to class every time. So again, what would you tell me to write? Now, if there is a minus here, what do you think happens? What is the difference from the previous case? Which one? The middle term, indeed. The middle term and nothing else. Ali, you had a question? Go ahead.
The st plus the st squared?
Uh,
On the bottom.
First term.
The previous page.
Yes, first term squared. First term squared plus 2 times the first term times the second term plus the second term squared. Better?
Yeah.
Is that clear?
Yeah.
Okay, so now I would like you to make up 2 examples. One with a positive and one with a negative. Anything you can think of. Okay, 3x squared plus 4y Anyone can give me the second one?
AX squared.
Which one?
AX squared.
AX squared, very good. Minus 7y squared. Perfect, awesome. Very good. Okay, what am I squaring and how many terms do I get? 3 in both cases, right? So all I have to do now is, remember the pattern. First term squared plus 2 times the first times the second plus the second term squared. So please give me the first term squared. If you need to write it on the side, write 3x squared squared, and you must apply this rule. So when I square 3x squared, what do I get?
9x to the 4th.
Do you all agree with 9x to the 4th? We copy the base, multiply the exponents, right? We're not adding the exponents, but multiplying them. Plus, let's write it out. What do I have to write out first? 2. Please dictate the first term.
3x.
Squared. Please dictate the second term. And then please give me 4y squared, second term squared. See how once we understand this, we cannot really go back to foiling because there is no need once we understand it. Now we have to simplify this. 2 times 3 times 4. How much is that? 2 times 3 is 24. X squared y plus 16y squared. And when we get to review factoring, we will be able to much easier look at this and come up with that because we understand the patterns. Okay, can anyone give us the second one? Using the pattern, remember first term squared minus 2 times the first times the second plus the second term squared. So, what will be the first term squared?
A squared x to the 4th.
Do you agree with a squared x to the 4th? Please say no if you don't.
Wait, say what?
When I square this, I use this property. Ax squared squared will be a squared x to the 4th. So we put a squared x to the 4th. Now, what do I have to write? Minus. Then what do I write? 2. Then what do I write?
4 times second time.
I have to write, yes. What is it?
A x squared
Good. Multiplied by?
7y squared.
Very good. And then plus. The last term is always positive.
49y to the 4th.
Any questions on this? It's not done yet because we have not simplified the middle term.
This escalated quickly.
We are only using the pattern. We didn't do anything. Is it not clear how we square a product? Is that what the difficulty is?
No, it is. It's just visually, it's a lot.
First term squared plus 2 times the first times the second plus the second term squared. This is this level, and we have to get to this level in this course. Okay? We have to simplify the middle term now. So I'm copying a squared x to the 4th. What would you say about the middle term?
Minus 2, minus 14.
Minus 14, very good.
14
A x
x
squared
squared y squared.
plus 49y to the 4th. Is this clear? Now, I would like to look at the last one, but what I would like you to do when we finish today, create more examples for yourselves. Okay? Just put whatever you want in here, put whatever you want in here, and square it. And then this would come in as a second nature. Same thing with minus. Any questions?
I have one, but I'll try.
Yes, yes. You want to give us an example?
No, I don't. I just.
Anyone wants to give us an example if we need to look at another one? Can anyone make up one?
3x squared plus
Let's say 3x squared y, because we already had something like that, plus,
4x squared y.
let's say 4z to the third. 4z to the third. Let me write it again because it's not very clear. 3x squared y plus 4z to the third, everything squared. Okay, what is the pattern again?
Equals
Try to repeat it with me. You don't have to repeat it out loud, but try to repeat it with me. First term squared. What will you say about the first term squared? What will you write?
9
9.
x to the fourth y squared.
Do you all agree that when we square the first term, we square each and every piece, as we said the formula is, right? The procedure is, I square this, I square this, I square this, and this is the first term. So now, what is the sign?
Plus
Plus. What do I have to write next?
2
2 let's write everything so for everyone to see. 2 multiplied by
3 x squared
y.
y
2 times the first term times
4z squared
4z to the third and plus,
4z cubed
which is 16 z to the, indeed. Now I have one more step to go back and simplify this. Any questions? Are you with me? Do we understand the pattern?
Can we slide it over a little bit? I think that's a little bit. I see it.
Okay, can anyone give us the simplified form now? It's not fully simplified. One more time, do we understand this? Do we understand the procedure? Yes? Okay, so can anyone give us the final simplified form?
9x to the fourth
9x to the fourth y squared plus
24x
24 again, x squared y z to the third and plus 16 z to the sixth. Is this enough? Is it clear? Yes, everyone? Make up 10 more examples. And once you practice with those, you should not forget. Any questions? Please don't be shy so I can move on. Is this clear? If you don't tell me what it is not clear, then I will not know what to address. Is this okay? 2 times 3 is 6, 6 times 4 is 24, and then x squared y and z cubed.
What'd you get from 16 z?
4 squared is 16. Z to the third squared, z to the sixth. Copy the base, multiply the exponents. It's the exponential rule. So if I have x, y to the third, I have x to the third, y to the third. And when I have z to the third, everything squared, I copy the base and multiply the exponents.
Okay, I see it.
Better?
Yeah, I just wasn't understanding like that second portion.
This one?
No, the like so 2 times 3x squared y.
So this is 2 times the first
So
term
that
times
whole
the second.
section, I wasn't understanding.
It's a product
I see how.
because there are 3 terms. This is the first term, this is the second term, and this
Right.
is the third term.
I just wasn't understanding how
That's
the
fine.
numbers were combining. I get how you get to 24,
In a
but I
product-
just didn't know that you could do that.
It's,
That's
it's
what I was
because it's a
struggling.
product.
Right.
So in a product, here's the answer. 2 times 3 times 4 is 4 times 2 times 3, is
Right.
3 times 2 times
Right.
4, is 4 times 2 times 3. You can rearrange them in a product the way you like.
Right.
The product is commutative and associative. Yeah. Okay, last one here. Is it clear that this last one is not the same with the previous two?
Correct.
Right. They must be the same A and the same A, and the same B and the same B. But the difference is one is plus and one is minus. So let's do FOIL for now and see what will you do next. So what will you say?
A squared plus AB.
minus AB
So it's a squared. It doesn't matter where you want to start. So okay, so minus ab and then plus ab.
plus B squared
It cannot be plus.
minus
Now look at this and say, oh, I know what happens here.
Is it A squared minus B
B
squared?
squared.
Indeed.
God bless you.
Indeed. So this is indeed only a squared minus b squared, and this is called the difference of squares. I do have 6:15 and I have to stop. I wish I didn't, but that's what it is. If you would like to just give me an example of this. And I would like to, first term plus second term, first term minus second term. So what would you say?
First term squared plus
It's the difference of squares. And you can make up any example you want. Okay, so let's say x plus 2 and x minus 2, and that's it. So what is it?
X squared minus 4.
Thank you for coming.